All right, so my presentation is called AI for the Human Experience. There's lots of content out there on this topic about AI for product managers and machine learning, this and that. But in my opinion, I don't think that AI is awfully useful unless people actually love it, people actually use it, and it starts to change their habits and the way they do their life. Here's a little bit about me. I started out my career some time ago. I was a data scientist. I founded an AI analytics startup. I eventually found my way and found myself in product. I also worked as a consultant, advising different companies on their AI strategy and how to build AI teams. And I've also been a board advisor on some companies that are very much involved with AI. And my mission for my career at this point is to empower businesses, not with AI, but with intelligence. And the way to get intelligence is to take the very best of the human intelligence and also the very best of the artificial intelligence and the analytics. And I personally believe that this is the way to make disruptive innovations with AI. I've worked, right now I'm at Oracle, I've worked at Adobe, in all these functions, advising different companies. I've seen lots of AI initiatives that have simply failed, that have not been awfully successful. And I've met with companies who've hired data scientists and been frustrated that they're not getting the ROI, the return on investment. They're struggling to see the value. My goal here, to put things very simply, and I'll go into more detail throughout my presentation, many of these failed AI initiatives are because they are approaching these initiatives in either a purely human intelligence type of approach or a purely artificial intelligence type of approach, rather than synergizing and taking the best to create a product that incorporates the best in class insights, best practices, best processes, and the best design from both of these disciplines. So I'm going to tell a little bit more about my story. This is when I was in grad school. I was in a PhD program, and I was always an innovator at heart. And so, but I was also drawn to AI. The data was fascinating to me. So I had this idea, I'm going to go get some advanced education, and then it's going to empower me to be a very effective innovator using AI, since it's this emerging thing. And at first, I was very intimidated. These equations, I just grabbed this paper, there's these complicated equations. And let me tell you, it gets much worse than what you're seeing right here. But once I finally started parsing apart what is actually happening, I realized that AI is actually very simple. And sometimes for some folks, there is sort of an incentive to make it seem more complicated than it really is, to make it seem like it's this unattainable science that you need some sort of deep knowledge or experience to finally understand. But I learned that that's actually a myth, and that you don't need a PhD, you don't need any sort of degree. Fundamentally, lots of the most impactful AI innovations are ridiculously simple. And especially in academia and sometimes data scientists, sometimes it's difficult for us to communicate like the simplicity of what this value really is. And the truth is that it's simple. And I'm going to parse things apart really right now a little bit and make it really simple and kind of describe the AI toolbox and how you can understand what tools you have available to you and which ones are most effective for which use cases. So there's two types of AI. And this is very, very generalized here, but there is machine learning models and there is scoring-based models. And most of the time when you're reading blogs, see stuff on LinkedIn, they just lump this together into AI. But these are they have very different principles, very different tools. Like you've got a saw and you've got a power drill. And sometimes people they hire a data scientist, and the data scientist is really trained at using a drill or a saw, but then the needs of the business are like, hey, we really need a saw, and the data scientists or the product people are thinking that they should be using the other tool. Or another example is you have a dentist and you have a toothache and you go to the doctor, or you have a stomach ache and you go to the dentist. So I'm going to parse this toolbox apart. Machine learning models is where you have a data set that is a ground truth data set. That means and these are the types of use cases that it's most useful for: forecasting, vision, and voice. And there's a bunch others, but these are some of the biggest themes that you'll see. For example, you're making an AI algorithm, some feature that detects your face on Facebook. The way that this works is that they have people go and they take pictures of Jaekob Chenina, of Ash Roberts, of Jeremy, and other folks, and they say, I know for a fact that this is Jaekob. I know for a fact that this is Ash Roberts. And they have a human being go and put a label on it. That's the word that we do. It's like a ground truth. And then you let the algorithm learn, and you say, hey, now algorithm, now I'm showing you a picture. I'm not going to tell you who it is, but take a guess at who it is. And then if they say, hey, this looks like Ash, and it's right, then you show the machine learning algorithm, you say, good job, that actually was Ash. That was the ground truth. Now, in the process of me teaching you this, you have learned, and now you'll be able to predict better going forward. So this machine learning models have a ground truth data set that it references and learns from. In the scoring-based models, so this is web search, recommendations, and personalization, there is no ground truth. There is no ground truth data that is being referenced, and it's a lot more subjective, and it requires you to use a lot more imagination. And I'm going to jump ahead of an example here for Google search. Google search does not use machine learning. It uses a scoring-based model. And for the data scientists, the very technical term that people use in academia is information retrieval. I think that sometimes we in academia, we don't do a really good job at like marketing our innovations. That's why people call it search and some other more trending terms, but people call it's information retrieval, and it's based on scores. So you see here, I've searched for machine learning. Here, machine learning Wikipedia comes up, and this information retrieval algorithm is basically a point system, where every time you have a link pointing to you, the page that's being evaluated, you boost your points by 3 points, 4 points, and then count. You just go through every website, 1, 2, 3, 4, 5. You have 15 websites pointing to you, and then for every website that you're pointing at, you decrease the score. So boost, 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 decrease, 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 and then you calculate your score. It's so simple. There's no ground truth, because if you ask the internet, hey, which website on the topic of machine learning is the most important website that we should look at? It's subjective. It's Google search's opinion that Wikipedia is the most important thing, but it's debatable. There's no ground truth. The fact that this picture of Jaekob Chenina or Ash Roberts is Jaekob Chenina, it's undebatable. It's ground truth. Scoring models, there's no ground truth, and it's subjective. And one thing that I'll highlight going forward is that the scoring-based models are like the best AI innovations are ridiculously simple. This is like a screenshot from the algorithm that Larry Page did before he founded Google. This is the PageRank algorithm, and it's really simple. And when I saw this, I was like, oh, this is so refreshing. Like some of these other PhD folks make these super complicated stuff, but look, Larry Page, he's an innovator and a business guy. He knows, keep it simple, and you will disrupt. You'll be way more disruptive if you keep your AI simple. So in 2013, something really important happened. And that was that some researchers, they put a GPU, they took graphics cards from video games, and they programmed what's called a neural network on a graphics card. And after that, algorithms that would fail 20% of the time, like to predict if this is a picture of a cat or a picture of a dog, they would fail 20% of the time with the best technology, machine learning that was out there. With the GPU, the algorithms could train and learn from the ground truth data 1,000 times, 10,000, 100,000 times faster. And so the algorithms could learn. And what happened previously is that the people that were trying to innovate, they would let the algorithms train for months and months, and it looked like it plateaued. They're like, oh, I guess they just plateau. The algorithms can't learn anymore. But it turns out when you use a GPU and you train the data 10,000 times faster, that it actually is getting better, but just ridiculously slowly. And so all of a sudden, now that it's fast forwarding so much faster, you can actually predict if this is a cat or a dog, or this is a Tesla car or whatever, with like a 0.001 margin of error. And it's like superhuman performance. And this is really cool. And this innovation has spurred a lot of the interest in AI over the last 7 years. But here's a really an insight, like this, looking at this toolbox, this innovation that was extremely disruptive, that is disrupting healthcare, that is disrupting agricultural, security systems, it's disrupting lots of these things. It applies a lot more. It has improved the performance of machine learning models much more than it has scoring-based models. So this is the analogy that I'll use. This is basically like the tortoise and the hare. Like the story, there's the rabbit jumps ahead really fast, and the tortoise is kind of slogging along, but eventually has a huge impact and ends up winning the race. The scoring-based models have not leapt ahead at the same speed that the machine learning models. And machine learning models, have been way more impactful in physical industries. So here's the insight here. There is the physical world and there is the virtual world. I'm involved with both of these worlds, but in SaaS, especially in the Utah product type community, there's a lot of people that are in business to business information technology, like some sales platform. There's business intelligence. Lots of these applications, these B2B SaaS applications, do not necessarily have digital assets. I mean, images or voice. Machine learning GPUs have disrupted vision and voice primarily. It has enhanced search, it has enhanced recommendation, but it has not like blown the performance out of the water. And so if you are in a physical industry, if you're in agriculture, if you are in manufacturing, if you are in healthcare, where you are dealing with physical objects, then machine learning, vision, voice is one of the most powerful toolbox that is disrupting those industries. If you are in SaaS, information technology, your toolbox, which did not jump ahead at like the rabbit and this tortoise and the hare analogy, but has still been very impactful, has been kind of improving all this time while like vision and voice made this skyrocket leap. It has been improving and disrupting things, in my opinion, much more than the GPU deep learning stuff for IT technologies. So I'm talking to both. I'm parsing across these toolboxes apart. Yes, GPU technology has affected the physical world much more dramatically than IT businesses. And I'll give you some examples now. The physical world here is, I've got a few examples here. Maybe I'll share some more later. But I'm going to talk about these virtual world products. Here we've got Amazon product recommendations. We don't even think of these as like, whoa, like it's an AI that's talking to me. But this replaces what a human being used to do. Think about it. Before, you used to go to J.Crew or Abercrombie and Fitch, you would try on a pair of jeans, and then a sales rep would say, hey, how do those fit? And you say, hey, they're too small, or I don't quite like the color. And while you're still in that changing booth, the sales rep would come and put like 3 more similar pairs of jeans for you to try out. Oh, wow, I like this one. Oh, you look great in it. This Amazon product recommendations is showing you similar products to that pair of jeans or that watch that you're trying on right now. It is literally replacing what used to require a human being to do. This is disruptive. Not every e-commerce company out there did this, and this has been a huge driver for Amazon's success. Netflix. This is also, and oh, by the way, these Amazon product recommendations are not driven by machine learning. It is a scoring based model. So, and I'm gonna give you an example of how this works. If you're looking at a watch, if the user is looking at a watch, and I've got these other watches, and if the watch has the same name, or like based on this number of matching words, like, oh, this is Apple Watch White. Oh, here's another Apple Watch size 14. Like it has 3 matching words. So for every matching word, boost the similarity score by 3 points. Remember I was talking about these point systems? Like, oh, boost this, like, oh, for every link, you boost the points. It's debatable. Is it ground truth that this golden watch is very similar and you might be interested? No, it's subjective. It's human beings sitting down and thinking about, well, what would tell me if it's similar or not? How would I help this human being do, what the sales rep does and show them similar items? So for every matching word, I'm going to boost the score by 1 point. And if someone put it in the catalog on the watch category, I'm just going to boost it by 10 points. Anything that doesn't get that 10-point boost probably shouldn't be shown in the first place. And so you have this ranking of like this, you have a bunch of other products that you could show. This has 50 points. Like, oh, if the color is the same, white, then boost the score by 5 points. It's just a point system. You don't need a PhD to understand this. You don't need to like rack your brain. It's a point system. And I have coded a product recommender similar to Amazon's product recommender in an afternoon. And I bet many of your developers could do the same thing. If you product people, you think MVP and optimize your V2, V3, MVP, you can code a product recommender in an afternoon. And you can say like number of matching words, or you can say like if product 1 equals product 2, boost the score. It's very simple. And then there's lots of optimizations you can do on it. You can incorporate more and more data points. Netflix, same thing. If the person has watched a movie before that's an action thriller, boost the score by 2 points. If they've watched a comedy and they gave it a like, if they just watched it, then just boost it by 2 points. But if they watched it and they gave it like a thumbs up, then boost it by 5 points. And then if they said give it a thumbs down, then decrease that by 2 points. And like, oh, count up the points, point. Oh, 80s action movies has the highest number of points. So let's show them the first carousel on Netflix is going to be 80s action movies. It's just counting points, and you could design it yourself. You could do it in Excel. You could say like, like there's this an Excel function that's like, if this cell has this value, then do this mathematical function. Anyone that has done like a little bit of more advanced Excel could code a recommender in Excel. It's not rocket science. Here is Zillow. And here's an email. When I was looking at houses in the Bay Area, I got this email, and let's make a afternoon recommender AI here. If the house is 1 mile away, boost the score by 5 points. If it's 2 miles away, then boost it by 2 points. If it's 5 miles away, that's pretty far, so just boost it by 1 point. Look, you've coded a recommender that's purely location based in 10 minutes. And then if you want to take it a level further, if the price is difference by $500, it's pretty close, so boost the score by this much. And then you can take it to the next level and incorporate more data points. And I'm sure, machine learning, this is all the scoring system, which has driven the majority of the success of these products that I'm showcasing. You can layer on machine learning. I'm not saying that machine learning has no application for IT products, but like, how would you use computer vision? Oh, well, here I'm using image recognition to see that this third house has plants. And the person spent 10 minutes looking at this house, and it has lots of pictures of bushes. And so I believe that this person must really like bushes. So if there's other houses that also have bushes and more greenery, and that seemed to be an appeal factor for this user, then boost the score by 2 points. Now that's getting more complicated. And that's where lots of people are hiring data science for. But if you're trying to test a machine learning AI product concept, don't think that you even need a data scientist in the first place. You can start things extremely simply. Look at these companies. These are the top 5 biggest tech companies: Google, Amazon, Facebook, Microsoft, Apple. Google's has become Google because of their information retrieval scoring-based innovation. Amazon has become Amazon very much because of their scoring-based information retrieval, search, recommender. I mean, all these terms are all pretty synonymous. Search, recommendation systems, information retrieval. It's like all kind of the same stuff. Amazon would not be Amazon without their recommenders, without these scoring systems. Facebook, there used to be MySpace. Do you remember on MySpace? You just go to, you navigate to other people's pages, but you don't, there was no feed. The Facebook feed is what disrupted MySpace because it is using a scoring system. If this person posts something and like I have this many, for every matching connection mutual connection, boost the number of point, that boosts the score of that by 2 points, 3 points. It's just a scoring system. You could code it also in an afternoon. And yes, they have optimized it, but it is fundamentally a scoring system that you could code in an afternoon. Now, 3 out of the 5, Microsoft and Apple are both doing lots of information retrieval, search and vision and all that stuff. But I can't say that Microsoft and Apple became Microsoft and Apple because of these scoring-based models. But look at this. The biggest companies in the world achieved the success by using what is a pretty old school, the search recommender stuff has been around for 30 years. It is the tortoise. If you're in IT, this is the tortoise that is winning the race. This is what you should spend your time learning on. I've taught online courses with like a variety of different platforms. And some of them were called AI for product managers, like machine learning for product managers. Like if you're in IT, you may not need to learn machine learning. You should learn how these scoring systems work. And fundamentally, they're very easy and you can make them better and better. And that, in my opinion, if you're in IT, is even more important than understanding machine learning. What is the common theme between all of these disruptive products? So the future of IT, I kind of summarized that. Basically what these products are all doing, these 3 products, Google, Amazon, Facebook, is they're doing something that's called personalization. And here's my definition of personalization. Personalization is the art of tailoring the consumer experience to the unique preferences of each human. It's about human beings. Because this doesn't only apply to business. This doesn't only apply to software. But if Ash Roberts says, hey, Jacob, how's your work going? How's your work going for, how are things? I will tell him a different story. I will personalize my update to Ash about my career. It will be different for Ash than if my grandma says, hey, Jacob, how is your work going? Why is it different? Because Ash has different data. He has different experiences. And I know a little bit about what Ash knows. And so I know that this data that I have, it's not stored in a database. It's not stored in like a spreadsheet. It's stored in my brain because I'm a human being. And I will personalize my conversation. I'm sure you've met some people that tell the same joke every time. This grandma, uncle, aunt, friend, they just tell the same jokes. And people that fail to personalize and are just kind of robotic and mechanical, they just are less likable. They're more difficult to talk to. If you are an effective human being, you will be very socially gifted people that I know, like even if skiing or carpentry, they're really good at finding those common interests and personalizing their conversation. They don't just like go on and on and on about the topic that's interesting to them. They figure out what you are interested in. What are your data points? And I'm going to personalize my communication to you. That is personalization. Human beings, we do this all day long. Google helps you personalize based on what you are looking for. You give Google a hint. Hey, this is what's on my mind. Can you help me out? And it responds to you the same way, a back and forth conversation. He says, hey, I think that this is going to be useful to you. It's personalizing based on what's on your mind. Amazon is personalizing based on the products you're shopping. Facebook is personalizing based on your connections. They're all providing personalization. And I think that if you're in IT, personalization, even if you're not in IT, personalization applies to all businesses. It doesn't matter if you're a retailer. It doesn't matter if you're in management consulting. Everyone needs to personalize their product offerings in many cases, and their communication around that product offering if you want to be an effective business. And so that's why this is my insight that I'm sharing with you. If you are in IT, and even if you're not in IT, even if you're in hardware, if Vivint has these webcams, great machine learning use case, like detecting when people come and ring your doorbell, that's awesome, pertains to the physical world. But even Vivint can benefit a lot from using personalization by personalizing their business to every single customer that expresses an interest or intent related to a home security system. So now, taking these insights, and I'm gonna look at the questions. I see some comments there. I'll get into those as soon as I get through the presentation. So keep posting those while they're on your minds. Here is another human-based principle. Humans are more likely to welcome contact after recently having had contact. I'm sure you've experienced this before, where you're messaging someone, and if you respond right away, then they respond back quickly. And if you take 2 days to respond, they take 2 days to respond. These are some very simple product features that have been around for a long time, but are still some of the hottest features. I'm right now in the digital marketing space. So the customers that I'm building products for are email marketers. And there's this methodology called RFM. It stands for recency, frequency, monetary. There's many variations of around this. And once again, this is not new. There's RFE, recency, frequency, engagement. Monetary is, if you're swiping your credit card. So recency is like, how long ago did you visit my e-commerce site? How frequently did you visit my e-commerce site? And how much money did you spend on my e-commerce site? For each of these three things, it's like boost the score, boost the score, boost the score. Hey, this is a hot lead. Like, give them a discount, target them, make sure that we retain them, make sure that we retarget them. Like, hey, did you forget about the jeans? That is recency, frequency, monetary. And then if you're like in B2B, usually it's a longer sales cycle. People are not swiping their credit cards, so they've adapted this to be RFE and RFD. The list goes on. And I'm going to show you here a real feature that is one of the hottest features in the Oracle Marketing Cloud, and it's called RFM. I'm just grabbing a screenshot here from the documentation. So here, this axis here, let's go full screen here. This axis right here is on the bottom is recency score. So basically, if they submit their email into your website, like, hey, subscribe to the newsletter, boom, they're going to have a recency score of 5 because it happened a day ago. And if they're using your website over and over, or you send them emails, they open it, click. If ignore and don't open your emails, every time you open an email from some retail brand, they actually get a notification that you opened it, even if you don't hit reply or anything. So open it, and when they also embed trackers into the links. So every time you click on a link, they get a notification. Oh, this person. Jaekob Chenina clicked on the link that we sent them. He opened the email, click. So that's how they do this. Open, click, boost the score. And you could make this very sophisticated. I have seen, there are very sophisticated RFM models out there, but if you go back like 10, 15 years, there were RFM models that were out there, like for every open, for every click, boost the score by 1, and then and then that boosts the frequency score. And then if it's 2 days, then it's a 5. If it's 6 days, then it's a 3. If it's 10 days. And so you could kind of create a rule-based system. Data scientists have obviously gotten a lot more sophisticated about this, but this is one of the, in the Oracle Marketing Cloud, there's quite a few AI features. And I've shown them to the consulting team. I've shown them to really big retail brands that you see in all of the shopping malls, that toy companies that all the kids play with, and they love this feature. And they love it for a couple reasons. Number one is because it's easy for them to understand. A marketer can say, okay, look, this person is just subscribed to the newsletter. They're in this yellow category. That means higher recency, but not a lot of frequency yet. That means may not be familiar with the brand. I'm going to start hitting them with emails that introduce them to the product catalog. Like, hey, did you know that we have, if you're REI or some, outdoor, like backcountry for Utah, check out, did you know that we have hiking gear? Did you know we have mountain bikes? Oh, I didn't know that they had those types of products. Now I'm going to start exploring them. The more that they engage, they go into this green category of recent and frequent interaction. And now this is like, these are where you're going to make the most money, from this green upper right corner. And then once they start fading out, like they were, I'm sure you've done this before. You found a brand you really like. You bought a pair of jeans and you're like, oh, I should have gotten the white one. Oh, I'll just buy both of them. So then you're going to be in this top right green bucket. But then once you're not buying for like 3 months, 6 months, 8 months, 9 months, you haven't needed to buy, you're going to start, your frequency is still going to remain high for some time, but the recency is going to go down. And then eventually it's going to become so old that the frequency is going to go down. And then and then they're going to try to reactivate you, like, oh, by the way, remember those jeans you bought? Like, look, we have a new one. So that's how the marketers are using this. They see which bucket you're in and they hit you with the relevant messages based on what stage you are. So this is a very simple, and has been very simple for many years, but it's human-centric for 2 reasons. Number one, it's human-centric because it's simple enough that the marketers can wrap their mind around what's going on and actually use it, unlike many of the other fancy AI features with tons of algorithms and sophistication. This is an awesome AI feature. It's marketers understand it and they use it and they love it. Number two, another reason why this is a human-centered feature is because it models a consumer's journey. You have gone through the same journey before. If you have bought something online from some retailer, you have gone through the same journey. You were new, and then maybe you didn't buy right away, so you got into this blue bucket, and then you bought a couple things and you got into the green bucket, and then you didn't buy, you went through every single one of these stages: yellow, blue, dark green, light blue, and these have different names. Some people call the dark green like champions or loyalists or VIP brand advocates. Everyone kind of comes up with their own terminology. Call it what you want, but this models the journey of real human beings. So it's a human-centered feature for the marketer, and it's a human-centered feature for the end consumer that's receiving the marketing communication. So that's one example of a really killer AI feature that is centered on humans. I'm going to show you another one. This one is called CLV. This is also from Oracle Marketing Cloud's technical documentation. This basically predicts the value because you're swiping your card, you're predicting how much value you have, like, oh, this person has spent $300, $400 on your brand, on your website. And then you can use machine learning. This is machine learning. This is not the scoring base, but you actually could create still a pretty comparable scoring based model that still kind of does something similar to this. But nonetheless, many people have been doing this with machine learning for quite some time now. And in fact, when I got my first job as a data scientist, this was one of the first features that I made. It was I was working for Nav, here in the community, you guys might know, and this was one of the, I created this. I wasn't the only person who's came up with this idea. I think that every data scientist that has ever come up, been in a company, they're like, ooh, what data do we have? Ooh, we have purchase data. Ooh, if we have purchase data, we can predict who's going to spend money. But I sort of came up with this. I coded it up for fun, as a side project while I was at Nav, and I was like, how do you use this? If this person is going to be really a valuable customer versus a less valuable customer, are you going to do worse email communication to your low value customers? And I could predict this, but I didn't know how to turn this into action. But now I've realized that this was incomplete, and what many data scientists try to do will be incomplete until it is married with the human intelligence. And I've worked with lots of retailers now in this marketing space, and I've finally learned where this is really useful. One really big golf retailer that I've worked with, they know that the pro golf players spend a lot more money on golf gear than the novice, let's give golf a try types of people. So they know their consumers. So they can use this to start, like low spenders, medium spenders, high spenders. They can like, and even the product descriptions for pro gear, it's more expensive, it's better quality, and like it's like, oh, this has a shaft of 67 millimeters, and the putting range is like, to a novice golf player, it's like, what are you talking about? Like the shaft width and like, but for when you're marketing to a novice person, you say like, it's very easy to swing. It's, these are the personas, and and you can map a journey. People can mature from being a novice golf player to a pro golf player. And that is the job of a product manager, of a marketing team, of people that really care a lot about empathy, to map a journey from like turning someone from an amateur golfer into a high spending pro golfer. And that is how you can actually use this feature in a very useful way. But if you have your data scientist working in a silo saying, go disrupt our product with machine learning and come up with some, I'm sure most data scientists have come up with this feature, and then they scratch their heads and they're like, well, what do I do with this? That is why my mission, my message to the world is that to create the best AI products, you need to marry human intelligence with artificial intelligence. One more AI feature that is a really hot feature, this is my third hot AI feature, is within the Oracle Marketing Cloud, is a send time optimization. This does use some machine learning, but you could also do it with a scoring-based system and human assumptions about like, oh, if this person opens emails every day on Tuesday, count it up and like count up the number of email opens for, Jaekob@gmail.com, and you just count it up, and then like, okay, well, he opens mostly on this day, so boom, recommended send time is Tuesdays in the morning. Or, oh, this person usually checks their email in the evenings. You could create a very non-machine learning based approach of send time optimization. I know that Oracle's team has incorporated more data points and used more advanced algorithms to take it to the next level and make it a lot more dynamic. And the send time optimization feature is yet another one of the hottest AI features that marketers are using. They love it because they can't possibly get to know every single person. And it personalized is also, once again, a third human-based AI feature, because it communicates to humans at not only the frequency and the message that is most relevant to them, but at the timing that they are most receptive and welcoming of marketing communication. So those are three of the hottest AI features in the Marketing Cloud. And they can be very simple. You can take them, you can optimize them, bring them to the next level. I talked about the customer journey. So that's my presentation in a nutshell. To really summarize, my mission here is to help people create better products by unifying human intelligence. Product managers, we do tons of customer research. We have tons of data in our brains about our customers. Data that sometimes the data scientists don't have because it's not stored in a spreadsheet. It's in, you've done qualitative customer research, you've done persona mapping with sticky notes, etc. You know your customers very well. If you rely on your data scientist to be the master of the data and you're not bringing your own human intelligence to the table, then it's going to be an incomplete feature. It's not going to delight the customers.